So a 20 Newton horizontal force gives a stone on the ground an acceleration of 4 meters per second square. So that's a force applied to the right of 20 newtons. It is on the ground, and that ground is Earth, so force of gravity down, force normal up. Vertically, we are balanced. We can say that the summation of forces in the y would be force of gravity minus force normal is equal to 0. You can choose to reverse those. Force normal minus force gravity equals 0. It's going to be the same thing. To the right, we've got force applied, and that's going to be equal to mass times acceleration. It's not balanced forces horizontally, so the net force is equal to mass times acceleration. What is the weight of the stone? Well, we need to figure out the mass in order to figure out the weight. The applied force is equal to mass times acceleration. Rearrange the equation to solve for mass, and we've got 20 divided by 4, so 5 kilograms is the mass. If 5 kilograms is the mass, the weight is going to be equal to force of gravity. Force of gravity is mg, mass times the acceleration of gravity, in this case 50 newtons. How far will the stone travel in 12 seconds if it begins from rest? We're looking for delta x in a 12-second time span. V naught is 0. And acceleration from the problem is 4 meters per second square. According to the variables that we have listed, we're going to calculate our answer with delta x is equal to v naught t plus 1/2 at squared. V naught t goes away because the initial velocity is 0. We have delta x is equal to 1/2 times 4 times 12 squared. Now 12 squared is 144. 1/2 of 4 is 2. So 2 times 144 is going to be 288 meters. Number 2, a 5 kilogram rocket, so we've got the mass at 5 kilograms, acted upon by an upward force of 59 newtons. So we go up 59 newtons due to the thrust, so we've got thrust as the force produced by its engines. What's the rocket's weight? Well, the weight is the force of gravity, calculated as mg, mass times the acceleration of gravity. On Earth, that's 10. So 5 times 10 will be 50. 50 newtons. What is the net force? Well, we can do our net force equations. There's nothing in the x, nothing acting horizontally that's been indicated in the problem. In the y, we're going to take the larger force and subtract the smaller force, so that way we always end up with a positive value. The upward thrust is 59, the downward force of gravity is 50, so we're going to say thrust minus the force of gravity. So the net force in this case would be thrust minus force of gravity, 59 newtons minus 50 newtons, and that's going to equal 9 newtons. Now 9 newtons is the net force, but we know the net force is equal to mass times the acceleration. So we can say that net force is equal to ma, net force is 9, m is 5, what is a? If we divide 5 to the other side, we're going to get 9 over 5. I believe that's 1.8, and then it'd be meters per second square is the acceleration. And that acceleration would be in the upwards direction. So we're going to watch the directions as we do this, and net force and acceleration are always in the same direction. A rope attached to an 80 Newton wagon. So 80 Newton wagon, that's telling us the force of gravity, the weight is 80 newtons for the wagon. Pulls it horizontally to the right. So we're going to have tension to the right with an acceleration of 0.5 meters per second square. Now the wagon's on the ground, so it has a force normal. It's balanced with the force of gravity because it's not accelerating vertically. And it's tension to the right because it's a rope. What is the mass of the wagon? Well, if the force of gravity is 80 newtons, the mass is 8. We're just going to take the weight and divide it by 10 to get the mass. What is the force causing this? What is the net force causing this acceleration? In the y direction, the net force is simply the force of tension. And the force of tension is equal to, or the net force is equal to, mass times acceleration. In this case, 8 times 0.5, giving us 4 newtons. We can go ahead and fill in that in the horizontal it's just force of tension, and in the vertical it's going to be force of gravity minus force normal. A 100 Newton force is applied to a 10 kilogram box, so I can throw 10 in the box real quick, across a horizontal surface. And I've got 100 newtons of force applied of 100 newtons to the right. A frictional force of 20 newtons exists, so that would be to the left. The force of 20 newtons to the left is going to oppose the motion. What is the magnitude of the acceleration of the box? How long will it, okay, that's a kinematics question after that. So as far as the magnitude of the acceleration of the blocks, we know that our net force is equal to mass times acceleration. In the x, we have Fa minus force of friction. In the vertical, we have force of gravity minus force normal. For the Fa minus force of friction, we would have that net force would be 100 minus 20, and that net force is equal to mass times acceleration, because there is an acceleration, because there's an imbalance of forces. So 100 minus 20 is 80, and that 80 is equal to mass times acceleration. The mass is 10, and then if we divide mass to the other side, we can solve for acceleration. So we got it all set up. 100 minus 20 is 80. 80 divided by 10 is 8. 8 meters per second square is the acceleration. Now, acceleration is the one variable that crosses over between forces and kinematics. So let's see what happens. How long? It's asking for time. The box to travel 50 meters, our delta x is 50 meters. Starts from rest, our v naught is 0. And don't forget, the acceleration is 8. We just solved for that. Since we have a displacement, we have an acceleration, we're looking for a time, and we have a v naught, the best equation for us to use is delta x is equal to v naught t plus 1/2 at squared. V naught t is 0 because v naught is 0, so that just kind of goes away. And if we're trying to isolate t, I'm going to leave it as t squared, just a little bit cleaner in my opinion, but that's okay. We're going to multiply both sides by 2 to get rid of the half on the right. We have 2 delta x is equal to at squared. Divide both sides by a, and I would get 2 delta x over a is equal to t squared. Let's go ahead and do the math. 2 times delta x would be 2 times 50 over a, which is 8, is equal to t squared. So 2 times 50 is 100. Divide that by 8, I think is 12 and a half, something like that, like 12 and a half. And the square root of 12 and a half is really what we're looking for. So let's grab a calculator and figure out what that's going to be. So square root of 12 is going to be more than 3 but less than 4, right? 3.54 seconds is the time. All right, a rubber ball weighs 49 newtons. That's not the mass. Mass is in kilograms. This is the weight. This is the force of gravity. So force of gravity equals 49 newtons. It is thrown upwards with a force of 69 newtons. So we have a force applied upwards of 69 newtons. What is the net force? Well, the net force comes from our net force equations. There's nothing in the x, nothing going along in the x direction, but in the y, we're going to take the larger minus the smaller. We would have 69 from force applied minus 49 from the force of gravity. So the net force is going to be 69 minus 49. I'm no genius, but I think that's going to be 20 newtons. The next question asks us, what acceleration does it cause? Well, we know the net force is equal to mass times acceleration. So if we've got our net force, if we divide by mass, we will get acceleration. So our net force of 20 divided by 4.9 is our acceleration. And when we do that division, we should get something less than 5. Let's see what it is in the calculator. 4.08 meters per second squared is the acceleration. Oh, great. Only asked one question, or 2 questions. That's great. A boy pushes horizontally on a 10 kilogram wagon. So we're going to put 10 in our box because that's the mass. The acceleration is 2.5, so we can't forget about that, but he is pushing, so we've got a force applied. It is near Earth for force of gravity. It's not accelerating, but it's on the ground vertically, so you have force normal. If friction force is a total of 50, so friction force opposes the motion, and that's 50, what's the magnitude of the force he exerted on it? Well, vertically, the summation of forces in the y would be force of gravity minus force normal, and that's 0 because it's all balanced up. But in the x, the net force is equal to mass times acceleration. The net force in the x would be Fa, force applied, minus Ff, force of friction. And we know that the net force is equal to mass times acceleration. We're solving for Fa, is the only one we don't know, so we're going to rearrange the equation to say that Fa is equal to mass times acceleration plus force of friction, just adding it to the other side. Mass is 10, acceleration from the problem is 2.5, and force of friction from the problem is 50. So 10 times 2.5 would be 25, plus 50 would be 75. So our force applied is 75 newtons. If the wagon starts from rest, so V naught is 0, how far will it travel in 7 seconds? So we're looking for delta x. Time is 7 seconds. And don't forget, earlier in the problem, they gave us the acceleration of 2.5. This gives us the same variables we've been using in kinematics throughout this entire worksheet. Our desired formula would be delta x is equal to V naught t plus 1/2 at squared. Fortunately, again, V naught is 0, so V naught t is 0. You can kind of circle that and take it out. We're solving for delta x, so is the equation, so we're in good shape. 1/2 times 2.5 times 7 squared. So delta x is equal to half of 2.5 would be 1 1/4 times 49, because 7 squared is 49. So whatever 1.25 times 49 is, 61.25 meters. Number 7. Oh, I had to fix that. I had a little mistake in the summation of forces in the y. It's going to be, in the x, it's Fa minus force of friction, and in the y, it's going to be force of gravity minus force normal. Now we all make mistakes. The mass of an elevator plus occupants is 752 kilograms. So we're going to throw a 752 in the box. The tension in the cable supporting the elevator is 8950 newtons. So tension up is 8950 newtons. What's the net force? Well, there's no forces acting horizontally, so it's only talking about vertical. Force of gravity does not change unless you add more mass or change planets. So the force of gravity would be 7,520. What's the net force? The net force is going to be force of tension minus force of gravity. And I chose that order because force of tension is bigger than force of gravity. Larger minus smaller keeps us positive. So our net force is going to be force of tension minus force of gravity, which is 8,950 minus 7,520. Once we do that math, let's see what we get. 1,430 newtons. What is the elevator's acceleration? Acceleration is net force is equal to mass times acceleration. We know the net force, it's 1430. We know the mass, it's 752, so divide mass to the other side. 1430 divided by 752. That will get us our acceleration. Put that into a calculator. We get 1.90 meters per second square for the acceleration. And it's accelerating upwards because the net force is upwards. Number 8, a race car weighs 6,958 newtons, so the force of gravity is 6,958 newtons. What is its mass? Well, if it's on Earth, we know the acceleration of gravity is 10, so we're just going to divide by 10 to get back to mass. So the mass should be 695.8. And force normal is going to be balanced to the force of gravity for a race car because it does not accelerate vertically, just horizontally. If it starts from rest, so V0 is 0, and travels 108 meters, so delta x is 108 meters, in 6 seconds, so time is 6 seconds, what is the magnitude of the acceleration? So we're looking for A. We're going to use kinematics to get the acceleration. So V0 is 0 meters per second because it started from rest. Delta x is 108 meters, time is 6 seconds, and we're looking for that pesky little acceleration. You can see that we're using kinematics to find acceleration. We can also use forces to find acceleration. That is the overlap. Our formula all day long, delta x is equal to V0 t plus 1/2 at squared. V0 is 0, so V0 t is 0. We kind of circle that, get it out of there, multiply both sides by 2. We get 2 delta x is equal to at squared. Divide both sides by t squared. 2 delta x over t squared is equal to a. So 2 times 108 divided by 36, because 6 squared is 36, that will get us our acceleration. So 216 divided by 36, I get 6 meters per second square is our acceleration. What is the magnitude of the net force? Well, we know net force is mass times acceleration. Mass is 695.8. Acceleration is 6. So we just take our 695.8 and we multiply by 6. And that gets us our net force. Because net force is mass times acceleration, you can either do the math for the summation of forces for the net force, or you can work the other side of the equation, mass times acceleration. In this case, net force is going to be 4,174.8 newtons. All right, number 9, a pulley holds a 10 newton weight. A man pulls on the rope with an upward force of 15 newtons. What acceleration does the weight experience? Well, if the weight is a 10 newton weight, the force of gravity is 10 newtons. So the mass would be 1 kilogram divided by 10. Then the man's going to pull with a 15 newton force upwards. So it's a total of 15 newtons force upwards in the form of force of tension. In the x direction, there's nothing happening. There's no forces. In the y direction, we have force of tension minus force of gravity because force of tension is the larger force. We know net force is equal to mass times acceleration. Divide both sides by mass. Our net force, which we said is force of tension minus force of gravity, divided by the mass would be our acceleration. So 5 meters per second squared is the acceleration. Number 10, a block initially at rest, so V0 is 0, on a frictional-free horizontal plane is acted on by a horizontal force of 25 newtons. So we have a force applied of 25 newtons going to the right. We'll always say it's to the right unless otherwise stated. If during 4 seconds, time equals 4 seconds, the block travels, delta x is 40 meters, what is the block's mass? What is the block's weight? Okay. Well, we've got some kinematics going on here. If from the kinematics, if we could get the acceleration, then we could put it into net force is equal to mass times acceleration. Let's start with that. So with the variables we have, we know delta x is equal to V0 t plus 1/2 at squared. V0 0, love it when V0 0, so we're going to circle that out and just mark it on gone. Delta x 40 is equal to 1/2 at squared. So multiply both sides by 2 to move the 1/2 over the 2 over. We have 2 delta x is equal to at squared. We're trying to get to a, so divide both sides by t squared. And we've got 2 delta x's, or 2 times 40, over t squared. T's 4, so t squared would be 16, is equal to a. So 2 times 40 is 80. 80 divided by 16. Is that 5? I think that's 5. Yeah, 5 meters per second square is our acceleration. Now that we have the acceleration and we have the net force is that 25 newtons to the right. They said there was no friction to the left. Our net force is mass times acceleration. Divide both sides by acceleration and you're solving for mass. The net force 25 divided by the acceleration of 5 is the mass. So 5 kilograms is the mass. If 5 kilograms is the mass, what's the block's weight? Well, if the mass is 5 kilograms, the weight would be 50 newtons, mass times 10, because weight is force of gravity. I'd like it if we go ahead and put in the vertical forces on our free body diagram. Force of gravity down, force normal up. And in the y, we have Fg minus force normal, and in the x, we have force applied. Number 11, a string can withstand a tension of 70 newtons. So going up, we have a force of tension of 70 newtons. If this string is used to support a 4 kilogram video camera, in the box we put a 4 for the mass, which was used to film gazelles. What maximum upward acceleration can be given? So what will the acceleration be given? So in the horizontal, we got nothing. In the vertical, we've got Ft minus Fg. We want to determine what the acceleration is. We know the net force is equal to mass times acceleration. Force of tension is 70 from the problem. Force of gravity is 40 because mass times 10. So when we can say the net force is force of tension minus force of gravity is equal to mass times acceleration, divide both sides by m, that solves for acceleration. 70 minus 40 over 4 is the acceleration. So 30 divided by 4 should be 7.5. 7.5 meters per second squared is the acceleration. And that was the only question that was asked here. Awesome. Number 12. An elevator accelerates downward at 1.5 meters per second squared. So if it accelerates downwards, that means my net force has to be down because they follow each other. If the elevator has a mass of 200 kilograms and is carrying 5 120 kilogram gazelles, so total mass, so we're going to take 120 times 5 plus 200. That gets me my total mass of 800. Find the tension in the supporting cable. So my force of gravity is 8,000, and then I got force of tension going up. There's nothing in the horizontal, no net force horizontally. Vertically, I have Fg minus Ft, and it's minus because we know we're accelerating downward, so we know the net force is downward. Fg minus Ft is my net force. Net force is mass times acceleration. So I've got Fg minus Ft is equal to m times a. I'm finding the tension. I know everything else. So if I said force of gravity plus mass times acceleration is equal to force of tension. So I would have 8,000 plus, minus 8,000 minus 800 times 1.5 is equal to force of tension. So 8,000 minus 1,200 should be 6,800 would be my force of tension. And that's 6,800 newtons.